We are going to start now the second part of the lecture, trigonometry and triangles, of the chapter 10, class 11th mathematics, straight lines. So in this lecture we will talk about the relation between orthocenter, incenter, ascribed circle, centroid, circumcircle and the pedal triangle. So the first result we have over here, it is the orthocenter of the triangle. It is the incenter of the pedal triangle. Second result we have is, if I1, I2, I3 are the centers of the ascribed circles which are opposite to the vertex ABC, and I is the in center of the circle ABC, then the pedal triangle, we are saying the pedal triangle of the triangle I1, I2, I3, and I is the orthocenter of the triangle I1, I2, I3. And the third result we are talking over here, it is the centroid of the triangle. It lies on the line joining the circumcenter to the orthocenter, and it divides it in the ratio 1:2. The next result we have is, the circle circumscribing the pedal triangle of a given triangle bisects the sides of the given triangle and also the line joining the vertices of the given triangle to the orthocenter of the given triangle, and this particular circle we are saying this is known as 9-point circle. This circle is called 9-point circle. And the last remark that we have now, it is that circumcenter of the pedal triangle of a given triangle, it bisects the line joining the circumcenter of the triangle to the orthocenter. So these are some, say, you can say properties or some remarks that you should always keep in mind regarding these circumcircle, incircle, pedal triangle, all these concepts. Now next we have is, in a triangle ABC, if small a, small b and small c, these represents the sides of the triangle, then we have to find the sides and angles of the pedal triangle. So we are talking about, this is the triangle ABC that we have, and DEF be the feet of the perpendicular from the vertices. We are saying from A we have drawn the perpendicular, from B we have drawn the perpendicular, and from C we have drawn the perpendicular. Then the triangle, this DEF, this is the pedal triangle, and in this triangle the angle HDC, we are saying it is, this is the point H where all these perpendiculars they meet. So we are saying in this angle we are talking about, it is HDC. This angle will be 90 degree, and the angle HEC, we are saying HEC, this is 90 degree, and this angle it is also 90 degree. So we are talking about HDC and E. We are talking about the point H, D, C and E. These 4 points, these are concyclic. So what we obtain is that angle, from this result we are saying the angle that we have over here, HDE, we are saying this angle HDE, we are talking about this angle over here, and the angle formed over here, this is HCE. Both these angles, these are equal because we will have a circle over here. These points, these are concyclic. We will have a circle over here, and both these angles, these are on the same arc, and that will be equal to 190 minus A. Similarly, we have HDBF. These 4 points, these are concyclic, and angle DHDF, that is equal to angle HBF, that is equal to 90 minus A. And from this result, we are having these two angles, these are equal to 90 minus A. These two angles, these are equal to 90 minus A. So what we get is that angle FDE, that will be equal to, we are using these two results and we obtain that the angle FDE, we are talking about this whole angle over here, this angle is equal to 180 degree minus 2A. Similarly, we have angle DEF is equal to 180 minus 2B and angle EFD is equal to 180 minus 2C. And these are the three angles of the pedal triangle. We are saying these are the required three angles of the pedal triangle. Next, we are talking about the triangle BFD. We are talking about the triangle BFD. These are the three vertices we are saying, and this is the triangle we are talking about. So in this triangle, the angle FDB, this angle we are saying, this angle is equal to this larger angle, this whole angle minus this smaller angle. We are talking about this whole angle minus this smaller angle. So it is 90 minus angle HDF, and angle HDF we already know, it is 90 minus 90 minus A. So we are saying this angle is equal to A. So the value of this angle we have, it is equal to A. So we are writing FD over sine B, that is equal to BF over sine A. So this implies us that FD is equal to sine B over sine A into BF. So now if we look at this value BF, we are talking about this length BF. So what we obtain is that BF over BC, that is equal to cos B. So the value of BF we obtain, it is BC cos B. So what we are getting from this is that this value is equal to, we are saying FD is equal to A sin B cos B over sin A, and this value is equal to 2R cos B sin B. So what we get from this is that FD is equal to B cos B. So this is the side length FD. Similarly, we can calculate the other two sides, one EF and second DE. So these are the three sides of the pedal triangle. So final result we have is that the three angles that we have, they are 180 minus 2A, 180 minus 2B and 180 minus 2C, and the three angles, three sides that we have, they are given by these. Well, these are the length of the three sides that we have. Now next we have to calculate the area, circumradius and in radius of the pedal triangle. So for area we know it is half the product of the sides. Suppose we are saying it is R sin 2B into R sin 2C into the value we have the sine of the included angle. So angle between these two sides, it is sine of 180 minus 2A. So the answer we obtain, it is 1 by 2 R square sine 2A sine 2B sine 2C. So this is the area of the triangle. Next we have to calculate is circumradius. So we are saying it is EF, if we are talking about the pedal triangle, over 2 times sine of the angle FDE. So this is equal to r sine 2a, this is the side, divided by 2 into sine of 180 minus 2a. So this is equal to r by 2. And the in radius of the pedal triangle, it is given by area of triangle DEF over semi perimeter of this triangle. So by substituting the values, it is 1 by 2 r square sine 2a sine 2b sine 2c. Then it is 2r sine a sine b sine c. So the formula we obtain, it is in this form. So these are the three values of the area of the pedal triangle, circumradius and in radius. So these are the three required values. Now next term we have, it is the centroid of a triangle. So we are saying in a triangle ABC, the midpoints of the side BC, CA and AB, they are D, E and F. This is the triangle ABC. This D, E and F, these are the midpoints of these sides. So the lines AD, we have drawn the line AD, we have drawn the line BE and we have drawn the line CF. These are called the medians of the triangle, and the point where these three medians they meet, that is called the centroid, and it is represented by capital G. And we have AG, the value, this length AG is to AD. The ratio of these two, it is 2 by 3. Similarly, the ratio we have for the other lines, it is 2:3. So now we are going to calculate the length of the medians and the angles that median make with the sides. So in this given figure, we are saying, if we are talking about this length AD, we are talking about the length AD, we can write for this triangle, we are writing AD square, that is equal to AC square plus CD square. We are talking about this length, that is equal to AC square plus CD square minus 2AC into CD into cos C. Now, so if we substitute the values over here, the side AC we have, it is this length AC, that we will have, it is B square. And when we are talking about CD, so CD will be A by 2, so this value we will have, it is A square by 4. This AC length again we have, it is B, and this CD length, it is A by 2. So what we obtain is that AD square, that is equal to B square plus A square by 4 minus AB into cos C, we can write it is B square plus A square minus C square divided by AB. These two terms get cancelled. So the value of AD we obtain, it is equal to 1 by 2 square root of 2 times B square plus 2 times C square minus A square. So this is the value of AD that we have, that is the length of the median AD. Similarly, we can calculate the length of the other two medians, length of the median BE, and this is the length of the median CF. This is the length of the median CF. Next, we have to calculate the angles. So suppose we are saying that the angle BAD, that is equal to beta. We are talking about this angle, it is beta, and this angle we have, it is gamma. So what we will have over here, it is sine gamma over sine C, that will be equal to DC over AD. And if we substitute the value over here, if we obtain the find the value of sine gamma, we obtain it is equal to this value. Similarly, the value of sine beta we obtain, it is in this form. So this sine gamma and sine beta, if we solve these values, we will obtain the angles that the median makes with the sides of this triangle. And similarly we can calculate the value of sine of theta. Theta is the angle that this median makes with the line BC, and we can calculate this angle sine of theta. Now the next term we have, it is x-central triangle. So we are talking about a triangle ABC, and if we are saying this I, this is the in center, and this I1, I2, I3, these are the x centers, and we draw a triangle. We are saying I1, I2, I3. This is the triangle we have drawn over here. Then this triangle we are saying this is called the x-central triangle. And the result that we have proved over here, it is that I1, I2, I3 is a triangle, and thus the triangle ABC, this is the pedal triangle of this X triangle I1, I2, I3. So how we are going to prove this is, we are saying that this IC, this is I and this is C, it bisects the angle ACB. This angle is bisected over here, and I2C bisects the angle ACM. This ACM we are saying it is over here, and this I2C is the bisector of this angle. So from these two what we obtain is that angle ICI2, that is equal to angle ACI. We are talking about ICI2, this whole angle, this is equal to sum of angle ACI and ACI2. We are saying it is sum of these two angles, and both these angles, these are half of angle ACB and half of angle ACM. So this is equal to half of angle ACB plus angle ACM. So this is equal to 1 by 2 into 180 degree, that is equal to 90 degree. And similarly we have angle ICI1, that is equal to 90 degree. So what we have proved is that I1, I2 is perpendicular to IC. We are talking about I1, I2, this line I1, I2 is perpendicular to the line IC. We are talking about these two lines, these are perpendicular to each other. And similarly we can prove that AI is perpendicular to I2, I3 and BI is perpendicular to I1, I3. So what we obtain from this is that I1, I2, I3 is a triangle, and this ABC triangle is basically the pedal triangle of the x-central triangle I1, I2, I3. Now next we have to calculate is sides and angles of the x-central triangle. So in this figure we are talking about the angle BI1C. We are talking about this angle BI1C. This is sum of these two angles BI1I and CI1I, and this angle we are saying this is equal to angle BCI. This is equal to angle BCI, and this angle is equal to angle CBI. So we are saying this is basically C by 2, this angle is B by 2, and sum of these two we are writing it is B plus C by 2. So that is equal to 90 minus A by 2. So what we are saying over here is that the angle I2, I1, I3, we are saying the angle I2, I1, I3, this is 90 minus A by 2. Similarly this angle, this will be 90 minus C by 2, and this angle at I2 it will be 90 minus B by 2. So these are the three angles of the x central triangle. Now we have to calculate the length of the sides. So we are writing I1C over I1I3, that is equal to cos of 90 minus a by 2. And from this we can calculate these calculations. These are shown over here. These calculations you can see at your own. We can see that the value of I1, I3 we obtain, that is equal to 4r cos of b by 2. This is basically the length of the side of the x central triangle. And similarly the length of other sides, they are I1, I2, that is equal to 4r cos c by 2, and I2, I3, that is equal to 4r cos a by 2. So these are the three sides of the x central triangle, and these are the three angles of the x central triangle. Next we have is the area and circumradius of x central triangle. So to calculate the area, we have substituted it in the formula half the product of two sides, that is the length of two sides we have calculated. One side it is 4r cos b by 2, another side it is 4r cos c by 2, and the angle between these two sides, sine of angle between these two sides, it is 90 minus a by 2. So on solving this we obtain the area delta is equal to 8r square cos a by 2 cos b by 2 cos c by 2. And if we are talking about the circumradius, if we have to calculate the circumradius, we are saying I2 I3 by 2 sine I2 I1 I3. If we calculate this value, that will be equal to 4r cos a by 2. We have substituted this in the formula of the circumradius corresponding to this x central triangle. The value of I2 I3 we know it is equal to this, and the angle we have it is 2 sine the angle I2 I1 I3, it is 90 minus a by 2. This value it is cos a by 2. These two values get cancelled, this get cancelled, so we are left with this 2r. So we are saying that the circumradius we have in this case, it is equal to 2r. So this is the area and the circumradius of the x central triangle. Next we have is distance between the inner center and the x center. So here we are talking about, this is the triangle ABC given to us. This is the triangle ABC. We are talking about the distance between inner center and the x center. So if we are talking about the angle IB I1, we are talking about this angle IB I1 and the angle IC I1. We are talking about these two angles. Both these angles, these are equal and they are equal to 90 degree. So we are saying that I1, this length I1 is the diameter of the circle, circumcircle of the triangle BCI. We are talking about this triangle BCI. We are talking about this triangle, and we are saying that I1, this will be the diameter of the circumcircle of the triangle BCI1. So from this result we can calculate I1, that is equal to BC over sine of BI1C, and by solving this value we will obtain that I1, the distance between the in center and the first x center corresponding to A, this distance we are talking about, it is 4r sine A by 2. And similarly we have the value of II2 and II3. These are the values we will have. These are the distance between the in center and the x centers. Now the next question we have is, if GHK denotes the side of a pedal triangle, then we have to prove this result. So GHK, these are the sides of pedal triangle. It means the value of G, it is A cos A, H, it is B cos B, these are the lengths of the sides, and K, it is C cos C. So if we substitute these values over here, we obtain it is G over A square plus H over B square plus K over C square. If we substitute these values over here, we obtain it is cos A upon A plus cos B upon B plus cos C upon C. Now the value of cos A, by the cosine formula, it is B square plus C square minus A square upon A, 2BC, so it becomes 2ABC. Next it is A square plus C square minus B square over 2ABC, and last it is A square plus B square minus C square over 2ABC. So if we solve all these values, the final answer we obtain it is A square plus B square plus C square divided by 2ABC, and this is what we have to prove. Next is, if O, H and G represent the circumcenter, orthocenter and centroid, then we have to prove that HG is to GO, that is equal to 2:1. So this triangle ABC is given. We are talking about this triangle ABC is given. Then we are talking about these points. It is O, H and G, and these 3 points, these are basically the circumcenter, orthocenter and centroid of this triangle. So we have two triangles. One, we are talking about the triangle AGH. I am marking this triangle over here. It is AGH. And second, we are talking about it is GMO. So for these two triangles, I am talking about, this is one triangle we have, it's HAG, and this is another triangle that we have, this is O and this is M. So for these two triangles, we are writing AH is equal to 2R cos A, OM is equal to R cos A. So if we divide both these values, the answer we obtain it is 2:1. So what we are saying is that AH over OM, that is equal to AG over GM. We can prove this result similarly, and that is equal to HG over GO, that is equal to 2:1, and this is what we have to prove. Next is prove that the distance between circumcenter and the orthocenter of a triangle ABC is R, square root of 1 minus 8 cos A cos B cos C. So we have considered the triangle ABC, and we are saying that O and P, these are the circumcenter and the orthocenters respectively. So if we are talking about OF, we are talking about OF, this length we are saying, it is perpendicular to AB. So what we obtain from this is that angle OAF is equal to 90 minus angle AOF. So we are saying this is 90 minus C. If we are talking about the angle OAP, we are talking about this angle over here. So this is equal to 90 minus angle, this value, it is not 90, it is A minus, the complete angle is A, minus angle OAF minus angle PAL. From this whole angle, we have subtracted these two angles. So the value, on substituting these values, we obtain this is equal to C minus B. This is the value we are getting. It is angle OAP is C minus B. So from this, what we are writing, OA is equal to R and PA is equal to 2R cos A. Now if we are talking about the triangle AOP, in this triangle we are saying, this is right angle triangle, this is in this triangle we are using the cosine formula to write this, it is OP square, that is equal to OA square plus PA square minus 2 times OA into PA into cos of angle OA P. And if we substitute these values over here, we obtain the final answer in this form, that it is OP is equal to R times square root of 1 minus 8 cos A cos B cos